Hey guys, you should have received your first learning packet this week, and I just wanted to take a few minutes and record a quick video to kind of help you walk through the first page of notes and do some examples with you. The first thing I have for you is I titled it Lesson 8.1. That's just so we can all sort of stay on the same page, so to speak, as we work through this. This is special right triangles, so we're going to look at two special right triangles and some of their properties, and then practice solving some problems together. So the first thing I want us to look at is this 45-45-90 triangle. We call it that because the angles are 45 degrees, and 90 degrees. So the first thing you'll notice is, or I hope you'll notice, is that this is an isosceles triangle. We know that because we have two angles that are the same. Alright, and earlier this year when we were learning about isosceles triangles, we also said that the two sides sort of opposite those angles are also congruent. Now, in a right triangle, those happen to be called the legs. So the legs of these triangles are always going to be congruent. Okay, so let's suppose that they were called X. Okay, so the legs are going to be X. The relationship, the thing that makes this triangle special is the relationship between the legs and the hypotenuse. The hypotenuse is always the square root of 2 times bigger than the leg. Okay, so another way we can think about that is whatever the leg was times the square root of 2. Okay, so we can think of the legs as being X, and we can think of the hypotenuse as being X times the square root of 2. Alright, so if you look at this first example, example 1, we have a 90 degree angle marked, we have 145. So by the triangle sum theorem, we know that the other one has to also be 45. So this is a 45-45-90 special right triangle, which means the properties that we talked about up in the notes and the ratios of those side lengths are always going to be true in a 45-45-90 triangle. All right, so we also have this side labeled as 8. Then we have this one X, and this other side here as Y. So another thing that's important to remember from previous lessons is that the legs of the right triangle are always the two sides that form the right angle. Okay, so that means this side and this side, because they form the right angle, would be considered the legs. Okay, so a little note, and it's kind of written up here in your notes. The legs, because this is an isosceles triangle, the legs are always congruent. So if one leg is 8, the other leg has to be 8. So I know then that X is also 8. Okay. Then according to our notes up here, if the leg is X, then the hypotenuse has to be X times the square root of 2. Well, in this case, the leg is 8. So that means the hypotenuse has to be 8 times the square root of 2. And this is in simplest form. We can't factor any perfect squares from 2 to simplify this any further. So 8 squared root of 2 is the answer for example 1. Okay, that one was pretty simple. And number 2 is kind of the same type of problem. We can see once again it's a 45-45-90. We have one of the legs marked, so that means the other leg has to be the same. Now look, it's tricky right here because we moved X and Y from the other one, so just be careful there. Here we can say Y is 25. So then X has to be 25 times the square root of 2 because it's the hypotenuse. If the leg is 25, the hypotenuse is 25 times the square root of 2. Okay, those were the easy ones. Now, for number 3, it's a little different scenario. For number 3, we have the hypotenuse marked, and we don't know what the legs are. Okay, so this one's not quite as direct. It's not difficult, it's just not as direct as just writing an answer. We're going to have to use what we learned up here at the top to write an equation for this. So we said we can think of the hypotenuse as x square root of 2, and here in this triangle that is equal to 19. Okay, well, we can simply solve this and figure out what x is, and x, remember, represents the leg. So if I divide both sides by the square root of 2, these two cancel. Square root of 2 over square root of 2 cancels out. So I have x equals 19 over the square root of 2. Okay, which is fine. No problem with that, except for it's not in simplest form. We learned in a previous lesson talking about radicals and square roots. You cannot have a radical in the denominator so that the problem is not simplified yet. So to simplify, we have to get rid of that radical in the denominator. Okay. So the strategy we used earlier this year to do that was this. We said if we take whatever that radical is and multiply that fraction by 1, but using this number, so square root of 2 over square root of 2, which is 1, we know that when you square a square root, so the square root of 2 times the square root of 2, that's just going to be 2. The square root symbol, you can think of those as like canceling out, so we're left with just 2. And in the numerator we have 19 times the square root of 2. Now, the square root of 2 is simplified. We no longer have a radical in the denominator, so this is the answer. Alright, so to go back up here and fill out, both of these legs are 19 square root of 2 over 2. For this one as well, 19 square root of 2 over 2. Okay, and I promise that we'll do some more examples of that one in a second. That one was a little more tricky. I want to go ahead and introduce the 30, 60, 90 special right triangle, and then we can work some examples of both. Okay, so this is also a special right triangle, 30, 60, 90. Notice we have 30 degrees marked, 60 degrees marked, and we know that this is the right angle or the 90 degree angle. This is not an isosceles triangle. The legs here are not the same, but anytime you have a 30, 60, 90 right triangle, the sides are always in the same ratio. So it's similar to the 45, 45, 90, but a little bit different. Here we can think of the short leg as x, so there's always going to be a short leg and a long leg. The long leg is x times the square root of 3, and the hypotenuse is always going to be 2x. Okay, so the hypotenuse is always double whatever the short leg is. Okay, now this little note is very, very helpful. This is big right here, because we have to know where all these things go. In the 45, 45, 90 it was easy because we only had really two parts, a leg and a hypotenuse, because the legs were the same size. But now we have two different legs. We have a short leg, long leg, and a hypotenuse. There are three things, so I need to make sure I can determine which is which. Okay, now we don't want to assume that one's shorter or longer, and we don't have to, thanks to this little extra note that we have. Alright, so this says the shorter leg is always opposite the 30-degree angle, and the longer leg is always opposite the 60-degree angle. Okay, so across from the 30-degree angle, this side all the way across from it down here, that's always going to be the short leg. So I'm going to write x there. Okay, across from the 60-degree angle, we're always going to have the long leg. So x times the square root of 3. And then, of course, we all know that across from the right angle, we have the hypotenuse. So that one's going to be 2x. Okay, so short leg is x, the long leg is x square root of 3, and the hypotenuse is going to be 2x. Alright, so take a look at number 4. If this is 60 degrees, and that's 90, that means this one has to be 30 degrees. So I'm just going to write that in. This is 30 degrees. Now, that's important because across from the 30-degree angle, we know we have the short leg. So 5 is the short leg, aka x, right? So I'm just going to, for this one, you don't have to do this every time. I'm just going to kind of try to help us see what's what. So we said, according to this, the short leg is represented by x. So I'm saying 5 is x. All right. The hypotenuse, I'm going to skip the long leg for a second. The hypotenuse, we said, is always 2x. Well, I just said x is 5. So that means the hypotenuse is 2 times 5, or just 10. Okay. So in this case, y is 10. Okay. Now, I know this says x. Don't worry about that. This is the long side. We're going to call it x times the square root of 3. And I've already said that x is 5. So this one would be 5 times the square root of 3. So I was given the short leg, 5. It's across from 30 degrees. I found the hypotenuse by multiplying that by 2, because the hypotenuse is always double the short leg, so 10. And then I simply took the short leg, which is 5, multiplied by the square root of 3, and got 5 times the square root of 3. So x is 5 square root of 3, and y is 10. Alright, on number 5, 14 is across from the 30-degree angle, so 14 is the short leg. Okay, if we double the short leg, we have the hypotenuse. Remember, 2 times x. If x is the short leg and we double it, we get the hypotenuse. So that means x is going to have to be 28, because 14 times 2 is 28. Okay. Now, if x is 14, and we said earlier that the long leg, this one is represented by y here, the long leg is going to be x times the square root of 3. Well, x in this case is 14. We're given that. So it's just simply 14 times the square root of 3. Okay, you see, I'm always keeping these three sort of this format. The short leg is x, the long leg is x times the square root of 3, the hypotenuse is 2x. Alright, in number 6, we start with the hypotenuse. Now, I've been saying that the hypotenuse is double the short leg. So if you think about that in reverse, we could say the short leg is half of the hypotenuse. Well, the short leg, remember, is across from the 30-degree angle, so that would be this one. So the short leg would have to be 16. And now that I have the short leg, I know that the long leg is just the short leg, x, times the square root of 3. So here the long leg would be 16 times the square root of 3. Okay, so we started off by taking the hypotenuse and halving it. Hypotenuse divided by 2 is equal to the short leg. Okay. Okay, number 7 is a lot like number 6. They give us the hypotenuse, so we can really quickly find the short leg, which has to be this one. It's represented by y in this problem. I know that because this is my 30-degree angle, and across from the 30-degree angle would be the short leg. The short leg is always half of the hypotenuse, so if my hypotenuse is 46, I can just half that, and I get 23. So y in this case is 23. After I know that y is 23, so this one's 23, this one has to be x times the square root of 3. Well, we just said that, quote, x, or the short leg, is 23, so this one would just be 23 times the square root of 3. 23 times the square root of 3. Okay, now number 8 is going to take a little more work. It's kind of like number 3, back up on the 45, 45, 90s. So let's look at what we have. This is the long leg, right? It's across from 60. And I don't really have a good way to just directly give the short or the hypotenuse based on that. I need to use the strategy of writing the equation again. So I'm going to take x times the square root of 3, because we said that's how we can represent the long leg, is equal to 20. I'm going to divide by the square root of 3 on both sides. So these two cancel. So I have x equals 20 over the square root of 3. But remember, this is not simplified. We do not want a radical in the denominator. So once again, I would multiply by the square root of 3 over the square root of 3. Okay, so in the numerator, I have 20, just go straight across. 20 times the square root of 3 would just be 20 square root of 3. And square root of 3 times the square root of 3 is just 3. So I have 20 times the square root of 3 over 3. Alright, and I just realized that they're being kind of sneaky with these letters. See, normally we call the short leg x, so I'm just going to rewrite it and change that to x and rewrite this. We'll make that y. We really don't care what the letters are because we're identifying them as short leg, long leg, hypotenuse. But just to kind of clear that up a little bit, x is 20 times the square root of 3 over 3. Okay, so then if that's the case, that's what my short leg is. The long one is always twice that. Okay, so how do I do that? If I take 2 and I multiply it by 20 square root of 3 over 3, I can think of this as 2 over 1. So I'm going to multiply straight across for my numerators and straight across for the denominators. So I would have 40 square root of 3 over 1 times 3 is 3. Okay, and that would be my hypotenuse. Okay, this is the last one, and because you're given that 9 times the square root of 3, most of you are probably thinking this is going to be the most difficult one, and you would be wrong. Now, we see that this is the long side. So we said the long side is always going to be written in this form, x times the square root of 3. But if you remember, x represents the short side, or the short leg. Well, that's this thing that's being multiplied by the square root of 3. Well, in this problem, 9 is being multiplied by the square root of 3. So that has to be the short leg. So the short leg is 9. Well, that was pretty simple. And then we've said if you take the short leg and you double it, that's what the hypotenuse is. Well, what's 9 times 2? 18. So y is 18. Okay, now that's just a brief rundown of special right triangles and a few examples of each. The most important thing to remember are that those ratios never change. So for the 45, 45, 90, like we did back up at the top of the page, for the 45, 45, 90, the legs are always can be represented as x, and then the hypotenuse would be x, or whatever the leg is, times the square root of 2. Okay. For the 30, 60, 90, remember that the short leg is always x, long leg is always x times the square root of 3, and the hypotenuse is always 2 times x. And then it's really important to remember that the short leg is across from the 30-degree angle, the long leg is across from the 60-degree angle, and then hopefully we all know that the hypotenuse is always across from the right angle. Okay, so on the next page you should have a page called Mixed Practice with several different 45, 45, 90s and 30, 60, 90 problems you can do. Hopefully you won't have any problems doing 10 through 18, and then when you get to 19, they start to get a little more tricky. I think you can still do them. You just want to you have this is what I'm talking about. You have like multiple triangles sort of stacked on top of each other. But I think if you just think about that as one thing at a time, just look at one triangle at a time, I don't think you'll have too much trouble with it. If you have questions, please send an email, send a remind, let me know. I can do some more videos explaining this and doing some more practice on this as needed. All right, see you later.